So we're comparing two exponential relations. So they're asking you to compare the initial value and compare the growth or decay factor. So the equation of two colonies of bacteria are shown below. Colony A has a P equals 102 to the power of T. Colony B has a population of 103 to the power of T. We will graph this using Desmos, okay? And then we're gonna discuss the difference in the graphs, okay? But before we do that, look at both equations and tell me about what's the similarity and what's the differences between the equations.
Initial value?
So what's their initial value?
100.
100, right? So they both have the same initial value of 100. Okay, so sounds good. So the initial value is the same, which is 100. What else can you tell me? Similarity or differences between the two?
Different base.
What's the base for the first one? And the second one? 3. So a base of 2, base of 3. What does it mean that you have a base of 2? What's happening to the population? Yeah, it's doubling, right? What's happening to the population in the second equation?
Tripling.
It's tripling. So which one's gonna grow faster? Right? So if you're thinking about it, if we're starting with 100, then it's gonna become 300, then it's gonna become 900, right? Well, the other one's gonna be 100, 200, 400, right? 800, so this is gonna grow. The second one's gonna grow much faster than the first one, okay? So let's look at the graphs. So Desmos, I've talked to you about Desmos, right? Not in this class? Desmos? Okay, so Desmos is an app that you can actually download on your computer, on your phone, or you can actually go on Google and then just press Desmos graphing, and you'll get something that looks like this. So Desmos is basically graphing technology, all right? If you already know what the equation is. As I said, you can download it on your phone or you can use it on Google. So if I'm gonna graph, I'm gonna write y equals to, you can't use letters p's and whatever, you have to use x and y, okay? So y equals to 100, bracket 2, and the power of x. So to do the power, you have to show the keyboard, and then there is power of 2, but we don't want power of 2, so we're gonna use that a to the power of b, and then write the letter x.
Sorry, what did I download it to get that?
You don't need to download it right now. You can go to the website and Google Desmos. And you don't have to do it right now. You can do it later on at your own time. How do you? The keyboard?
Yeah.
There's a keyboard button right here at the bottom. I can't make this higher. At the bottom left, there is a keyboard. Okay? And that A to the power of B, that's your power button. Okay? So if you want to check your work and to check if your equation, if your graph looks right compared to the equation, you can use Desmos to check it. You can make it smaller, you can make it bigger with the plus and minus on the right side. So you zoom in or zoom out. Are we all good with that? Then I'm gonna write the second equation, so it's gonna be y equals 100 bracket 3 to the power of x. So the blue one is the second one because you see it's indicated by a blue next to the equation. And then the red one is the first equation, it's indicated with red dot next to the equation. So this is how I know which one is which. So if you look at these two graphs, right? You can see that the blue one is growing much faster than the red one. I can actually change my scale, like it's, you can play around with it later on, but you can press on that wrench and then you can change the scale. Let's say you want to look at 100 in the Y values, like you want to look at 100 to 200 or to 700. Right, and then we'll show you the scale between these two. Okay, so you see that the blue one is growing faster than the red one. Okay, so this is called Desmos. So let's type, I'm not gonna bring the graph here, I'm just gonna type what's the similarities and what's the differences between the two. So both graphs have the same y-intercept. Or initial value. And calling B grows faster than colony A.
Can we not grab this in Excel?
You can't, I don't know if you can do that in Excel. Because Excel will graph points. I don't know if it would graph equations. You probably can. But I have to check. All right. The second question is asking you, how would the graph of colony A change if there were 200 bacteria initially?
Initial value change.
The initial value changed, so as your other values, right? Instead of starting at 100 and then 200 and then 400, you're gonna start at 200 and then it's gonna double to 400 and then it's gonna double to 800 and so on, right? So it's gonna shift. I'm just gonna do something here. Let me just check. 100 to the power of x. Just trying something. Yeah, no. No. All right. So we're gonna answer this one. It's gonna be the vertical, the y-intercept. Increases by 100, causing the graph to increase slightly faster than the original graph. Can you guys see this? All right, so now we're gonna use Excel to graph points and then to do an exponential regression. So we can use exponential regression. To model data that appear to lie along an exponential curve and produce a curve of best fit. Okay, so let's look at this example. So in year 1921, 1931, 41, all the way to 2001, BC population in millions is given. So we're gonna have to use a graphing technology and then to determine the exponential relation that best fits the data above, where X is the number of years since 1921. So I want you to read this very carefully. So I'm gonna repeat what I just said. So use a graphing technology to determine the exponential relation of X that best fit the data above, where X is the number of years since 1921. What does that mean? What do they want you to graph?
After 1921.
So 1921 would be year what? Your initial year, which is year 0, right? And anything after 1921 is going to be year 10, year 20, right? Depending on how much you're going up by, right? So 1921 is going to be your year 0. What would be 1931?
Year 10.
Year 10, because that's 10 years after 1921. So on the x-axis, you're not putting 1921, 1931, 1941. You're actually entering 0, 10, what would this be? 20, 30, 40, 50, 60, 70, and 80. Okay? So you have to read the question very carefully. Because when the question states where X is the number of years since 1921, so that means 1921 is your year 0. That's what you enter on your x-axis. Do you understand that? Okay? So, let's enter this information in Excel and let's see what happens. Make sure that you enter your numbers correctly. And then as usual, you're gonna highlight, you're gonna go to insert, press on the scatter plot, and pick the first one. Okay? The question is very clear and they want you to find an exponential regression, right? The question is very clear. It's not asking you for linear, it's not asking you for quadratic, it's asking you for exponential, okay? The first thing you wanna do is you wanna add your titles to the axis titles. So what would be on the y-axis? Population in million. So it's very important that you include that. What would be on the x-axis?
Year since 1921.
Year since 1921. And the chart title would be BC population in million since 1920. So this is making the graph look. The first one, yeah. I want you to the online one is not
The other one's like, it's very figure it shows like that.
Okay, I'll get into this in a second. Okay, let me finish the questions. Let me okay? Try to use the one on the computer for now. All right, how can I make an exponential regression? What do I do?
Click, right click, look, dot.
Click, right click, add trend line, right? So that comes up with all these options. The first one is your exponential. And then you're gonna display equation on chart, display R squared. So, look at this. Eyes on the board for a second, please. My equation is 0.5252 e to the power of 0.0268x. Is this what you're supposed to be for your equation to look like? No. But 90% of the time or 99% of the time, this is how the equation that Excel is going to give you. So we're going to have to make it the way that we want it to be, which is the initial value, the base, the power of x. So this right here, which is 0.5252, that's your initial value. Okay? So that's your initial value. We're not going to change that. We're going to keep it. The thing that we're going to change is we're going to change e to the power of 0.0268. And how are we going to change it? You're going to find e on your calculator. So there's a e on a letter e on your calculator. You're going to press that. And then you're going to make it to the power of whatever the number is. Should be a small e.
It says on some I guess it's exponential. It says the speed.
No. It's not the exponential. Oh, it's right here. So you shift this one. Okay? And then power, and then whatever the power is. Did you find it? So it's the top right here. So you do shift and this, and then you put power, and then you write the power 0.0268. Yeah, good. So enter 0.0268. Shift, and this comes along to the one. That's e to the power. Yeah. Okay. Okay, and then your answer should be 120 something, right?
Error.
Syntax error.
Yeah.
Okay, don't put the power for you guys. Okay, so once you get something like this, you can't leave it like this. I will give you a big X because I don't want it like this. I want to know what your decay or growth factor is. So I want you to change it in the calculator and give me the proper equation. So when I copy this, and you guys know how to copy it, now I'm gonna copy it into my own thing.
You remember me?
So we're gonna write the equation, and the equation is going to be y equal 0.5252 1.027 to the power of x. Don't forget the power of x. Yes, it is small. You don't see it right here, but there is an x right here. Okay? What does the value of a and b represent in this case? So what's the value of a?
0.525.
So what does it represent? So the initial population, or the population in what year?
1921.
Yeah. So the population of BC in 1921, which is 0.5252 million. Yeah?
You know, that really bothers me. Like, I don't know those things.
You don't
I'm
know.
trying, but I can't get it. Like, when you have the worded question asking you like that, I don't know what words to put.
So basically, you're gonna see what these numbers mean. What do they mean? What do they mean when I say 0.5252 1.027 to the power of x? What does 0.5252 mean? What does that represent? You know it represents the initial population, right? But you know that the initial population is 1927, not when BC was created by God, right? It's in 1921 when we started the studies, or when we started counting whatever, right? So this is why we say that in 1921. How about B? What does B represent? What's the word for B? What do we call this? The growth factor. Factor. So B is your growth factor. What would be your growth rate? How can you find it? Minus 1. So B is your growth factor. So the growth rate is, so the population grew at a rate of, and I do 1.027 minus 1, which is going to give me 0.027, which is 2.7%. So the population grew at a rate of 2.7% per year. How can you estimate the population of BC in 1985?
Yes.
You can guess? Sure, but how can I find it? What do I know?
Get the number of years and then use your growth rate.
So you can actually use your formula, which is right here, right? How many years is it between 1921 and 1985? How can I find that?
1985 minus 21.
You subtract them, right? subtract 1985 minus 1921, that would be how many years after 1921 that is, right? And then you plug that value in for what? For x. Because x is the number of years. So all what you have to do is 5252, 1.027 to the power of 64, and plug that into your calculator, and you should be getting about 2.9 million. Don't forget your therefore statement. I'm not yet removing marks for therefore statement, but I will be on the exam. The population in 1985 was 2.9 million. Can you I'm just gonna try something here. I don't know what's happening with this. I'll get back to this page. Just